Hey guys, welcome to my first tutorial video using Maya. My name's Varun, and I'm going to show you how to use the script that I wrote that creates a simple spring that is dynamic or has dynamic controls and that you can use in rigging. So let's get started. The first thing you need to do is obviously download the script if you haven't already. There's going to be a link to that in the description. It's hosted on Creative Crash. It's a pretty good site to download all kinds of plugins and scripts and all kinds of other things for various 3D modeling programs. So I have the script just dragged to a shelf button here. So I'm going to click this and create it. So what you see that happens is this little window pops up, and this is the creations control box, and what it contains is pretty much self-explanatory. This is how many coils the spring is going to have. This is the curve degree, and this one's a little less obvious. To create the spring, basically I have created a NURB circle profile and a helical path, and what happens is the circular profile is extruded along this helical path, and the helical path is obviously a curve, and curves have a degree, so changing this will change the degree of the curve. I'm going to leave it at 3. You can pretty much always leave it at 3 and it works just fine. So I'm just going to use the default settings, change them if you want, and I'm going to hit create. So what you notice is a few things. First of all, it's created the spring. It has open ends, which I'll look to fix later, but let's ignore that for now. It's created this little window, and it's added a new layer. The first thing I want to do is explain the layer and how it's related to these things. So you have this slider box here. It contains the stretch and the thickness. Those attributes are directly tied to the attributes of the spring itself, that are these two attributes, respectively. I had to name them that way just because the script was exploding otherwise. I'm not sure why. Anyway, by changing this attribute here, basically what it does is it changes the scale Y attribute of the parent curve you used to make it. And what that does is it makes the spring look like it's extending without just trying to scale this mesh. Because if we try to do that, this is what happens. We get this weird stretching ribbony thing here, and that's not really realistic looking, so let's just undo that. What it does, like I said, is changes the scale Y of the curve, which prevents you from getting that ribbon looking thing. And now changing this thickness here will change basically the thickness of the coil. So let's do that and see what happens. Now notice how the radius of this circular profile here has grown. Basically, by changing the radius of the circular profile, we change the radius or thickness of the spring. And that's pretty much how I've set it up to have these dynamic controls. So let's move on to actually doing some rigging. Alright, so as you can see, I've just modeled this simple little piston, and what we're going to do is make a little rig that has the spring wrapped around the piston to act as basically a shock absorber or something like that. So if you're rigging like a car or anything that has a shock absorber, you might find this useful. The first thing to do is to rig up the piston itself, and that's pretty easy. So what we want to do first is create joints. Now if you're using this in a much larger model that has other parts, obviously you'll have some sort of joint chains, but basically you want to have one joint for the section that each part of the piston is going to rotate around. So that's going to be this cylindrical thing here, and I guess the top of this thing here too. So let's do that. Let's create the first joint. Let's put that, make that there, and then we're going to move it over so it's centered along this thing's axis. So I'm going to do that, and that's the first joint we need. And I'm going to create the second joint while we're at it. I just duplicated that one, and it creates another joint. It's just conveniently labeled joint 2. I'm going to very roughly move it to the top of this guy here, and that'll make a good enough approximation of where it should be. You just want it roughly in the center, and that's honestly close enough. So that's good. One thing to notice is that I did not make the joints a joint chain by parenting them or anything, and that's just because when I make a piston, I usually don't. It's simpler if the two parts of the piston aren't parented. So anyway, let's get down to it. The first thing you want to do is parent constrain various sections of each joint to the mesh, or the other way around. So I've selected this joint. What I want to do is I want to parent constrain this mesh to that joint. So we'll just go to constrain, parent, and I'm going to make sure I have all the right settings. And I'm just going to do that by resetting the settings. And one thing you want to make sure you have is maintain offset. That'll be important just so if the transformations aren't zeroed or anything, it'll work out nicely. So let's hit add. And what you'll see now is that this object is now constrained to this joint. Works out nicely. Cool. And now the thing we want to do is parent constrain this mesh here to this joint. So let's select this joint, this mesh, constrain parent. Done. Well, that was easy. So now we have these meshes constrained to these joints. Now the interesting part comes from how we constrain the joints. And that's actually, once again, pretty easy. We want the joint for this section down here to be point constrained or even parent constrained to this area. We'll do point constrained because we're doing a piston. So let's make that point constraint. We select this first because this is the target of the constraint, and the joint is the object we want to constrain. And then we go to constrain point. So now the joint is constrained to this, which will make the whole thing move. That's good. Now the other thing we want to do is constrain the aim of this joint to this joint. And that's important so that this joint will always face this one. So let's do that. Select the target. We select what we want to constrain. Would constrain, aim. I'm going to reset the settings again because I've been doing some various projects. And I'm going to make sure I have maintain offset hit again. I'm going to hit add. So now let's test that out and see what happens when we move this guy. You'll notice that the top section actually does move, and it's always pointing towards that joint, which is basically what we want. We now just have to do the same thing for this. We're going to constrain the aim of this joint back to this joint, so they're aim constrained to each other. So let's do that. We'll select the target and what we want to constrain. We'll constrain aim. So let's see what happens now. Well, that was pretty simple. Our piston seems to be working pretty well. Obviously, if you move this across the z direction, it's going to look kind of weird. So, just because this is going to rotate all wonky, and you don't want that. So, anyway, that's set up pretty much fine. So, the next thing we want to do is get the spring working. So, I'm just going to undo all those transformations that I made and make sure it gets back in its original spot. Alright, so now that we have our piston set up and working all nicely, even with the top and bottom, which is cool, oops, which you can see here, what we want to do is find a way to use the spring with it. Now this is where things start to get a little more complicated. The first thing I want to do is to basically lay the piston either vertically or flat. I'm going to choose vertically because it's going to be really easy to do that. I'm going to move this straight over here so it's pretty much straight up. That makes it easy to do. When you're doing this, if you're doing it for something you want to look really good, make sure this joint is really in the center of this top face. It'll make everything easier for you. I'm going to move this up some just so there's some space to work there. Cool. Okay, and what we need to do now is basically create a few tools or a few objects that we'll use to make this thing move and interact with the spring. That's pretty easy. We're just going to use a couple of locators to do it, and what we're going to do is create the two locators. I'm going to hide this for now, and you just go to create, locator, and again, create, locator. Don't worry about that area you just saw, it was nothing. And what we want to do is position these locators where we'd want either endpoint of the spring relative to the model. So one thing I want to turn on is X-ray so we can kind of see where our locators are. So anyway, I think a good position for either locator would probably be where the shaft kind of ends of each side of the piston. So right about here is good. and oops, select that, and right about here, maybe a little higher, just say right about there. So now that we've put the locators there, we need to attach them to the rig itself. That's going to be pretty easy. We're just going to parent constrain them to the joints that they're closest to. Once again, constrain parent. So that one's done. And same thing for this one. Constrain parent. Now the locator should move with the rest of the mesh. And it does. That's good. And they move in relatively good directions, which is also important. So they always stay relatively in the same position in the piston. So that works out nicely. Alright. I'm going to leave it back up top again. So here's what we want to do now. Now that we have these two locators, what we need to do is find the distance between them, so we can relate that to how far the spring should be extended. Now, there's a couple ways to do this, and the easiest way is honestly using the distance between node. Maya has a node that calculates the distance between 2 points, and you can connect the inputs as the position of two objects, which is really nice and easy. So let's do that. The one I'm going to use is the distance between node. I'm going to use the position of this one and the position of this one. Distance between obviously has two inputs for the position of the 2 points. So what we want to do is we want to bring up the hypergraph connections. I have that brought up, so I'm going to drag that over here now. So let's create a new node. That's going to be under rendering, create render node, even though it's not necessarily a render node. And you can just type in this box distance, and it's going to make this distance between node. So that'll work really well. And now what we want to do is we want to connect the locator's positions to the distance between nodes. So I believe we want to calculate connect the locators themselves and not the locator shapes. So let's find our two locators. Locator 1's right here, locator 2's here. And now that we have our two locator nodes here, we can start connecting the positions of the locator nodes to the points the distance between nodes going to use. So to do that, just click on either one of the locator nodes. Middle mouse drag all the way over to the distance between node. Press other, and then the connection editor should pop up. And what you want to do is you want to connect the translate node of the locator to point 1 of the distance between node. So let's find translate. Here it is. You want to expand the menu for this and point 1 and connect translate x to point 1x, translate y to point 1y, etc., etc. Okay, and then close that. Let's do the same thing for locator 2, except make sure we connect it to point 2 of the distance between node. Again, click other, find translate, expand that and that, translate x, point 2x, etc., etc. Alright, so now we have our locator's positions inputting to the distance between node. So now what we can do is basically use this distance between node to output something related to the stretchiness of our spring. And that should be pretty easy. Honestly, the easiest way to do it is to probably just connect the distance between to the stretch value of your spring just directly. So I'll do that now. Okay, so to do that, what we want to do is first minimize this. And let's actually create a spring now. I'm going to turn off X-ray. And what I'm going to do is I'm going to make the spring's height just 1. And you'll see why that is in a minute, just so it's a little easier than having to write an expression that's a little more complicated. And for now, I'm just going to decide that I want the degree to be 3, and the radius I'll have to play with a little bit, but let's just take a wild guess and say a radius of maybe, I don't know, 1.5. Oops, it's not working. 1.5, and coils, we'll make it maybe 8. So let's create that. And here it's created your spring, which is good. So now what we need to do is take this and position it first at the bottom of this piston, or bottom of the piston's shaft. So let's do that. Let's move this up here and very roughly put it here. And once we've done that, we can pretty much just leave it here. The one thing we want to do is to parent constrain the spring, which is a surface, to the joint we had down here. So let's hide that. Let's select the joint we have. Now we select the spring, constrain, parent. Now, just to make sure we did that right, cool, everything seems to be working. Now what we want to do is something that's actually pretty simple. All we have to do at this point is connect the stretch attribute of our spring to the distance between the two locators. So we're going to open up the hypergraph again, and let's find our spring. Actually, just to make sure we have all the right things in the hypergraph, I realized the problem is we're going to select the things that are going to be important in making this last connection, which is going to be the spring itself, and I believe just the two locators. So we shift select the two locators, and what we're going to do is we're going to go to Window, Hypergraph, Connections. And that should do it. Alright, so the spring's name is Curve1 Sir XTR. And in the hypergraph, you can see it right here. Don't worry about all the other connections, but basically what we need to do is just find the node for the spring and the node for the distance between node. So now the last thing to do is just to connect the distance between to the stretch attribute of the circle, or of the spring. So once again, we just middle mouse drag from distance between to the spring's shape node, or the spring's mesh node, hit other, and what we do is we connect distance to stretchy. And we hit close, and if we minimize this, show it, you'll see that it's done. And really that's about it. So if we move this, spring stretches, move it this way, stretches still. And that's really all you need to do this. And you can hide this layer called spring control layer, and that's just going to hide the path and the profile curve used to make the spring. So that's really all you need to know to do this. So yeah, there's your piston and there's your spring. Whoops. And I hope you enjoy it. If you like it, subscribe. I'll be posting more videos, and feel free to post any sort of questions. Thanks, guys.